Right, okay. You can hear me right. Good afternoon. My name's Graham Hastings. I'm the head of computing at St John's College School, which is in Grange Road, just over the way there. And I've been teaching computing since 1984, so a long time. And I saw it all go wrong. We started with BBCs and everything was fine, and then we got IBM clones, I think they're called, and then we got the ICT curriculum, and we started teaching Microsoft Office and programming and coding, which is what we started with, then got left by the wayside. So I became quite disillusioned, having taught ICT for about 15 years. And then I heard that there was a group of teachers in Cambridge who were like-minded and had started an organisation called CAS, Computing in School, which you may have heard of. And their mission was to try and get things changed and bring back computing. And led by Simon Peyton-Jones, they started lobbying government, and they lobbied anybody who would listen to them. And then eventually, in 2013, we were asked to form a working group to review the ICT program of study. And we did that, and we immediately decided it wasn't fit for purpose, and we chucked it in the bin and replaced it with the computing curriculum, which is what we now teach in schools. That was statutory from September 2014. And so, I mean, a lot of people now ask me the question, well, why teach computing to young children? And there are a number of reasons. I mean, it's intellectually stimulating. It teaches generic skills that have nothing to do with computing. I was mowing my lawn this morning and I thought, you know, am I using the best algorithm to mow this lawn? Could I save more petrol and time if I, instead of going round the plum tree and up the top of the lawn, if I started by moving the trampoline and doing that? And you know, this is applying sort of computational thinking to everyday life. And if we can teach children to do that, irrespective of whether they're ever going to become a programmer, that's a really useful skill for them to learn. And the sooner they learn that, the better. So the younger the children, the better. And I was quite adamant that we should include the teaching of algorithms right back at the beginning of Key Stage 1. And we had to fight because people thought we were mad, you know, but we fought for it, and the government eventually, the guy from the nice guy from Mr. Go's office eventually agreed with us. And so children as young as 5 are taught the word algorithm, and they start playing with algorithms from a very early age. It's fun. I teach computing, and I really enjoy it because I see how much the children enjoy it. It's a really enjoyable subject to teach, but it also supports other areas of the curriculum, maths obviously, but you can link it to any area of the curriculum. I do a lot of work with the DT, Design and Technology Department, and that's really what I'm kind of going to talk about in a minute. And also, it gives them a foundation that they can then take into secondary schools if they want to carry on and pursue computing at secondary school, GCSE, A-level and beyond. And that's the same reason we teach science at primary schools. You know, we don't wait until children are 15 or 16 and start teaching them science. They learn about science from right back at the beginning of primary school, and that enables the secondary schools to build on that knowledge. Now, if we left computing until secondary schools, they would be starting from a much earlier starting point and would have wasted a number of years. Now, when I started, it was the BBC. The BBC Computer Literacy Project had been going for a couple of years when I first started teaching, and some of you may know the history of that. In fact, I arrived at my first school the same year as their BBC. And the interesting thing about the BBC was that it was only really when, I think the then Secretary of State, I think it might have been Margaret Thatcher, I don't think it would be correct, but I think it was Margaret Thatcher, decided to put a BBC microcomputer in every primary school, that things really started moving. And that created an explosion in children's interest in microcomputers. There were loads of microcomputers around in those days. I mean, there was a new model arriving on the market almost every month at that point. The BBC picked on the Acorn as the device they were going to use because they wanted to standardise. They realised if you're going to put these things in schools and you're going to provide training, and they created a whole series of BBC programmes to train teachers and people how to use these things, then it had to be standard. because the training had to be transferable. It had to, from school to school, from year to year. And if you didn't standardise, you created a lot of problems. So they were very wise to standardise on a device, and therefore on a language. So everybody at school learned BBC Basic, which is what I started teaching children in those days. And there was no software. I mean, if you wanted a computer game, you had to write the game yourself, or you bought a magazine and you laboriously typed code. Children got very good at debugging because often the magazines had errors, printing errors in, and they had to sort them out. And hacking was the way that most children learned those days. And that spawned the golden generation, and what I call the golden generation. Some of you may actually be children of that golden generation. A lot of people I suspect here are. And that was the golden generation that then preceded the generation that we've got now, which is the Microsoft Office applications generation, where we've been teaching them how to use Microsoft Office and very little. So the lost generation is what I call them. The main interest for me was really the first time I found that you could plug things into the back of the BBC and make things happen. I've always been interested in engineering and building things and making things move. And then when I found that you could do that, and the children saw that they could also do it, they really became engaged. And I thought, well, physical computing, control technology is something that I can use then to draw children in. So a lot of children, they found programming, coding quite dry, theoretical, could be quite frustrating and boring, but to motivate them and engage them, if they can build something with some motors and some lights, and they can actually then make it do things or respond, then that was the kind of the driving motivation to keep them going, to struggle through the tedious debugging. And also, it's much easier to see when you've got an error in your program. If the light's supposed to come on, it doesn't come on, there's something wrong. So physical computing for me was the thing. And having developed a fascination then, I've stayed with it. And I've always, whatever school I've been in, I've been taught in many, many schools since then, I've always run computing clubs that do some physical computing. The big problem that we're seeing in schools now is that the boxes that we plug things into are disappearing as Windows PCs come to the end of their natural life. In primary schools, they're being replaced by iPads and tablets. So it makes it very difficult to interface with a computer. It's not that easy with a Windows PC. You need to buy an interface, and there are plenty of them on the market, and you can do lots of good control technology using these interfaces in Windows PCs. But once you've got an iPad, things start to get very tricky. Everything's locked down. Nobody's building interfaces that I've heard of yet for control technology in schools for the iPad. So we're in danger of it's in danger of becoming impossible to teach physical computing and control technology with the hardware that schools are now investing in. And that's kind of where I see the Raspberry Pi coming in. So you might be wondering what's this got to do with the Raspberry Pi. I see that the Raspberry Pi has tremendous potential for enabling schools to set up affordable control workstations when they no longer have Windows PCs. The mission of the Raspberry Pi was actually, I think, even up to when he first came up with the idea. The idea was that to recreate the days of the BBC Micro, or the microcomputers, probably wasn't BBCs, but children were programming with ZX Spectrums or whatever in their bedrooms, and that's how he started. And he thought that we can get children back into coding if we can get an affordable device in their hands that they can use in their bedrooms. I've got a 10-year-old son, and Xbox or Raspberry Pi, I'm afraid there's no context, it's Xbox every time. And I think, much as his mission is a laudable one, it's not going to happen, because when he first started playing with the BBC Micro, there was nothing else. Now there's so much else, that children have to kind of draw them away from the Raspberry Pi, that it's not going to happen in the way that we would like it to. However, if you put Raspberry Pis in primary schools, then you could possibly recreate the situation that we had back in the mid-80s, where the schools are enthusing the children, they're teaching them how to use the device, and it may then be that some of the children ask their parents if they could have the device to use at home and may start using it at home. But without that support in school, that initial enthusing in school, I don't think it is really going to happen. I'd quite like some data from the Raspberry Pi Foundation. If they, I don't know how many are sold now. I mean, I heard it was between 1.5 million and 5 million. Does anybody know how many? About 5 million, yeah. So, how many of those are actually in the hands of children? And I suspect very few. How many are regularly used by children? Even fewer. I know a lot of my students have got Raspberry Pis. They took them out of the box, looked at them, and they've gone back in the box and they haven't touched them. A lot of my students have got Raspberry Pis, but don't use them because the Xbox is far more fun and far easier to use. So I think the schools need to do this, and the younger you can get children engaged in coding, the better, because they're much more amenable to new ideas when they're younger. By the time, if you leave it to the secondary schools, by the time they're 11, 12, 13, they've already decided what they want to do, what they don't want to do. But at 7, 8 and 9, children will do anything that you want them to do if it's fun and engaging. So you've got no problem getting children into coding in primary schools. There are enormous issues though with the Raspberry Pi. I've done a lot of experimenting with it. I do use it for teaching. I do whole class teaching with the Raspberry Pi, and I mainly do control technology. I use the GPIO box actually that's on one of the stands out there. I have a class set of those. The children find it very, very easy to use them. They have no problem connecting their models that they made in D&T to them, and they're programming them in Scratch. So you've got a perfect combination of Scratch, which is a language they learn anyway, an easy language, a child-friendly language, and the GPIO interface, which is very child-friendly. I did try working with breadboards and GPIO pins. I've got a whole line of Raspberry Pis now in my office that don't work because the kids have, they burnt them out. Whereas with a child-friendly interface that's designed for children to use, they don't have to do any soldering. They just simply plug big plugs in and their models, and they can then be controlled, or they can plug sensors in. They can do sensing and control work. What I would really like, the kind of gauntlet I would throw down for the Raspberry Pi Foundation to pick up is, what I'd really like is them to produce some standard stuff for primary school teachers to use. A standard SD card that has what primary schools need on it and only what primary schools need on it. Something that's not going to change, every few months, because teacher training is expensive, and if you have to then keep retraining, you just end up with a lot of money wasted, a lot of frustration. You want to be able to train teachers that this is what you need and this is how it works, and we're not going to change that every 6 months. So a standard Raspberry Pi, a standard SD card. If the Raspberry Pi Foundation could also develop a standard training program, then they might get somewhere. But at the moment, primary schools are not buying Raspberry Pis. If they are given them, they're generally speaking not using them. And there's a missed opportunity that is a crying shame. And if we don't get Raspberry Pis in school and tablets replace Windows PCs, I can't see how we're going to be able to do physical computing and control technology in 5 years' time. So that's really my kind of mission is to get the Raspberry Pi Foundation to take seriously the primary schools and the needs of primary schools, and make the most of an opportunity there that's going begging at the moment. I think I'm more or less out of time, am I now? So if anybody's got any questions and they want to ask me about anything, I'm around for a bit, but that's it. It's not an encouraging talk, I'm afraid, but hopefully, other people can get behind it. Governors, school governors, or whatever, any school governors, contact the Raspberry Pi Foundation.